Welcome to this lesson on average versus instantaneous velocity. Today, we're going to explore motion snapshots and understand how velocity can be measured over time intervals versus at specific moments. These two concepts are fundamental to understanding how objects move through space. Before we dive into the differences, let's first understand what velocity actually means. Velocity describes how fast an object moves and in which direction. It's calculated by taking the displacement, which is the change in position, and dividing it by the time taken. This gives us a complete picture of an object's motion, including both speed and direction. Average velocity represents the total displacement over a time interval. It's written as v bar equals delta x divided by delta t here. Delta x represents the change in position, and delta t represents the change in time. Average velocity tells us the overall rate of motion between 2 points, regardless of what happened in between. Let's look at a simple example. Imagine a car travels 100 meters in 5 seconds. To find the average velocity, we divide 100 meters by 5 seconds. This gives us v bar equals 20 meters per second. This value represents the car's overall rate of motion during those 5 seconds, even if the car sped up or slowed down during the journey. Now let's talk about instantaneous velocity. Unlike average velocity, instantaneous velocity tells us the velocity at a specific moment in time. Mathematically, it's expressed as v equals the limit as delta t approaches 0 of delta x divided by delta t. This means we're looking at an infinitesimally small time interval, essentially capturing the velocity at one precise instant. Here's a helpful way to think about instantaneous velocity. When you're driving a car and you look at your speedometer, it shows your speed at that exact moment. It's not telling you your average speed for the entire trip. That reading on your speedometer is instantaneous velocity in action. It captures precisely how fast you're moving right now. The key difference between these two concepts is the time frame they represent. Average velocity is measured over a time interval, looking at the big picture of motion from start to finish. Instantaneous velocity, on the other hand, is measured at a specific moment, giving us a snapshot of motion at one particular instant in time. We can visualize these concepts using a position time graph. Average velocity corresponds to the slope of the secant line, which connects 2 points on the curve representing the start and end of our time interval. Instantaneous velocity corresponds to the slope of the tangent line, which touches the curve at just 1 point, representing that specific moment in time. Let's recap the key points. Average velocity measures overall motion, giving us the big picture of how an object traveled from one position to another. Instantaneous velocity captures precise moments, telling us exactly how fast an object is moving at any given instant. Both concepts describe how objects move through space, but they give us different perspectives on motion. Understanding both is essential for analyzing movement in physics.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.